Right, so this is it's design week 5, and we will talk about insulation. We already finished infiltration heat loss and transmission heat loss. We talked about how can we counteract or fight infiltration, and insulation is another way to mitigate infiltration and also transmission heat loss. It's good to have an idea of what's available in the market, and this market always keep evolving. There's new material all the time, and there's new ways to do insulation. And it's also a very creative area for you to come up with ideas on how to do insulation. If we understand insulation, we can come up with ways to use cheaper material, stuff that's more eco-friendly, and stuff that's really easier to install. The cost of insulation is trifold. It's the cost of disposal of the old material, the cost of the insulation itself, and the cost of installation.
So what do the glass fibers do in fiberglass insulation?
Well, we'll talk about it. Talk about fiberglass, we'll talk about cellulose, we'll talk about blown insulation, about all this kind of insulation. If there is something we did not mention, please let me know, because again, every time I look, there's always new stuff. It's really rapid field, and it's becoming very, very lucrative. There are some people who make a living just out of doing blown insulation. There's a guy I see always in the infomercials, not infomercials, those flyers for blown insulation. And it's very simple, it does the job, but we have to understand how does it work. So we'll talk about insulation types, what is available there in the market. Facing and barriers, how do we put insulation in facing and barriers? What is facing and what is barrier? Barrier is something we put inside the wall to eliminate the air migration. It's kind of like wearing what they call it, a windbreaker. It's a very light coat that basically just stops the air from coming into your body. So in some places you do not need a thick coat, just a windbreaker will be fine to eliminate the moisture from coming inside your body and also stop the blowing wind from cooling your body. Retrofitting insulation, that's if somebody built a very uninsulated house, and you go into the house and you find that this house is leaking air all over the place. What can we do to retrofit insulation into place, and what are the techniques that we can do? And again, that's something you also have to inspect if you're going to buy a house. What is the insulation situation? Sometimes you have to break into one of the walls to see what does the wall look like, what kind of insulation is available, and how much will it cost you to add in some insulation. Insulating new construction. Now there are a lot of laws and regulation about insulating new construction. That was not there like 10 years ago or even recently, and you will not get a license for construction, or the house will not be approved until you get these things done. One of them, for example, now by law you have to insulate your basement floor, but once you dig the hole and do the foundation, you have to insulate the entire floor. Why? They have discovered that there are a lot of gases that come from the ground, like radon, that can go into your basement and eventually be bad for you. Like radon can cause cancer, and it's a natural gas. So it's really important to seal your house. There are a lot of houses as well that has been grandfathered in. I have a house that's been in the family for 150 years. They're not going to enforce the laws on you. It's only on new installations. But for example, a lot of boilers now, they have to have the Energy Star stamp on it that is approved for new installation. But if you have an old boiler that has the efficiency of 60% and it's still working, you don't want to change it, they cannot force you to change it. However, once it breaks, probably you're not going to find parts and you will be forced to change that into a new one. And again, the thought is, I might have an old house that I'm keeping as historical. I'm not using the house as much. Why would I put a new boiler in it if I have to? If I'm not using it as much. So we talked about heat loss, and the insulation has to do with the U factor. We know how to calculate that from the resistance over here. So 3 to 6 times the heat loss than infiltration. So if you have infiltration loss of 30%, probably this is more through the wall. And if you touch the inside of the wall in the winter and it's cold, that means that you do not have really good insulation. if you see a lot of condensation in your wall, or like even the studs, you know there's really bad insulation. So, which means that the entire time your heater is on, you're losing heat to the outside. And if you go with the infrared camera, probably you'll see how you are heating the outside of the house. You're receiving a lot of heat to the outside. Insulation reduces the transmission losses by increasing the R value. So as you increase the R value, you are reducing the U factor. So the smaller this number, the less heat loss you have in this equation. And that's what we're looking for. We cannot control the temperature difference, especially if you can go lower inside your house, but there's a limit to how low you go. I've heard some people keep their house at 50, but I don't think that's reasonable. If you can, that's fine. But let's say the problem with keeping your house is 50, if anything, like if you have a cold wave somehow, and you're not in the house, and something craps out, you might freeze the pipe, and that's going to be a big issue. If you have frozen pipes, that's a big issue, because you have to go through the walls and replace all those pipes. There are some ways where you can melt water inside the pipes, but if you're lucky and the pipe will not burst, that'll be good, but if the pipe bursts, you have to go and change the pipe. So you want to keep the temperature at a reasonable level, but so 60 is reasonable. So that's the delta T. We cannot do much about that besides just controlling the inside temperature. And the area, that's something done for. The walls are already been built. I cannot change the area. So one thing we can do is adding insulation and reducing insulation. We also want to provide uniform temperature throughout the surface. So why is that? Have you heard of ice dams in attics? You get some cold spots, and those cold spots or hot spots in the ceiling eventually will melt the ice, then freeze, and melt and freeze, and eventually you'll have an accumulation of ice, which is not something you want. And also if you don't have uniform surface area, probably you're gonna have condensation in some areas. So eventually you want to have uniform temperature throughout the surface. We also want to prevent wintertime condensation, which is an issue because why is condensation bad? It's going to ruin your paint. It's going to deteriorate the air quality in the house, and if you have more moisture, probably you're going to have some more mildew. And moisture is also an issue with what? Another example why you don't want moisture inside the house? Mold. And also for windows. If your windows always like damp or have a lot of condensation, you're not going to be able to see through it, and you'll always have to clean it. So that's another issue that you don't want to have with condensation. And in the winter again, if you have condensation in your house, I'll show you how you can stop this from happening. So either your window is really not well insulated, or your house is a little bit has too much humidity than it's supposed to. So insulation can also add some structural strength to cavities. If you have a dry wall that is around 6 inches, you can tell the wall is not really that sturdy. Also, some doors like this one, for example, it looks very flimsy because it's hollow. So if you have some thin walls, if you reinforce that with with foam from the inside, that'll make it more sturdy. So insulation can add more sturdiness to the structure. And the last thing is the noise and vibration. So especially if you live in an apartment building, that's another thing you want to think about. By not adding insulation, you're probably helping the sound travel throughout your walls. So I told you about that building that I used to live in, and the construction company skipped on having insulation between the floors. And what happens is if anybody walks in town, you will hear them and the whole building will vibrate. And also it did have an issue with heat going from up and down. So you want to pay attention to that when it comes to noise. Between rooms is also an issue. Even if you have a house, you don't want the room noise transfer. And there are some installations that are designated for noise and noise control. Okay, any questions? I want to talk about R value, which is, we said R value is related to something called thermal conductivity, right? Remember that from the first class? And that is the K value. So you want to think about that, what happened here? The R value. So what do you remember when we said that air is a good insulator? If we can keep it in place, but air is always moving. So what happens when you have foam is you have some pockets in the foam. Those little microscopic pockets have air in them, and it's trapped, so it will not move as much. So what happens if you compress that air? What do you lose?
Pockets.
Yeah, you lose the pocket, and you lose the resistance, you lose the conductivity. So that's going to be an issue. And so density has something to do with the air pockets and how much temperature you lose. And there are some material here that, this graph tells you the density, pound per cubic foot, and the R value. And if you see the same material, as we increase the density, we increase the R value, then at some point, it starts to goes down. So when we think of on a microscopic level, if we have foam, let's say this is foam. We have little pockets here. This has air. So you want this filling here of material to be of good insulation. And one of the best insulators is fiberglass. Fiberglass is it's woven fibers out of glass, and it does not have, it happens that it doesn't have good thermal conductivity. What else is a good insulator material? Hay, what about flannel, wool? These material, not only they trap air, they also have really bad conductivity. They don't conduct a lot of temperature. So let's say this is fiberglass. We have our air pockets in here. If we increase the density, which means the material is going to be heavier, and we have the same number of cavities, but they are squished now. It's a really big squished. What happened?
Smaller.
Yeah, the smaller. We still have some resistance, but it's not as much as before. So at some point, if it's too loose, okay, let's make a too loose one. Which is mostly a lot of air pockets. If it's too loose, you're basically having air. And then probably it's not, again, it's bigger cavities, which means air has the ability to move too much. And we said air inside keeps moving, it's not still. If you can't keep air still, that would be a great thing, but it does not stay still. It's always moves, it always circulates. So if it's too big, it's not going to have good thermal conductivity. If it's too small, it's not. And that for somebody who does a lot of material testing to do that. So fiberglass, and what is cellulose? Let's see the phone. What is cellulose?
Plant fiber.
Huh?
Plant fiber.
Yeah, what else?
Like sponge.
You never heard of cellulose? It's a fancy word for newspaper. It's a cellulose material, so when they say blown cellulose fiber, that's basically processed newspaper.
Just recycled, like
Yeah.
paper.
They recycle it and they wash it with material that make it fiber coated. So it's practical if you do it right, and I'll show you what are the
So is
things
that
that
the
mix
spray
together.
foam insulation then?
Huh?
Is that the spray foam?
No,
There's a plant in Belchertown that does that.
Huh?
There's a plant in
Yeah,
Belchertown
yeah.
that does that.
It's a good idea to make use of used papers, you know, but it has to be done right, and I'll tell you how. I'll show you what's the key factor there. But I want you to remember the density. Density is something very important. important to think about, and this is the reason. We need the right density. Where you look at this curve, you want to be at the peak. After that, the R value will go down. Cellulose is different, goes down, and glass fiber is expensive, and it's not recommended for some applications because it can be airborne, and that's really not good for to be in your lungs. What are some of the good insulators around us? Foam, polyethylene,
Denim,
huh?
denim.
Denim is cotton. Cotton is not a really good insulator. Huh? Weight is a lot. Doesn't say, oh, even though your jeans is very thick, it feels cool. Why? Cotton breathes better. What if you have ceramic is actually not a good insulator. Solids. Rubber is good. Polymers are good. Asbestos are really great and natural and cheap. But the problem with asbestos is when it becomes airborne, it causes cancer. These tiles here are asbestos. They're good in place. Unless you cut them and it becomes airborne, there's no problem. There's, huh?
Why do you asbestos tiles legal, but the asbestos insulation?
This is not, this is an old installation from the 60s. You're not allowed to install this again, but if you have it, you keep it for now. And if we were to replace this floor, we need to have some special company that come, isolate the area and take them out. So, if you go to old houses and you see some insulation that you cannot identify, be careful, ask around before you start cutting into it, especially around piping, because asbestos was very sticky and it's easy to form and easy to remove. What are other insulations? We talked about foam. Foams come in different shapes. Polyethylene. There's something called aerogel, which is, it comes in sheets, like fabric sheets. It's around like 1 or 2 millimeters, and it has really good insulation
What
value.
about that bubble wrap ductwork insulation?
They're also good, yeah. The bubble wrap that has foil on each sides, it does insulation.
Dirt? With dirt?
Mixed with the other gravel, yes, it could be insulating. In Africa, they use dirt, use mud mixed with hay. So the hay will provide some kind of insulation, although the mud will be cohesive. Huh? Animal fur, wool. Wool is one of the best materials so far for clothing, for insulation. You can buy like small wool vest and it will be very, very warm. And the thing is, it has really, really bad conductivity, and also it has a lot of fibers which will trap some air in between. So think about trapping air, and think also about the material itself. What if we made this foam out of metal or ceramic? It's not going to be as effective because you're going to see something through here. So look at the heat movement through this insulation. Like in here, you'll have a lot of conduction going on, and heat will still move through, and some heat will go through the bubble, and we'll have some convection going on, and goes from the other side, and so on. So you have both conduction and also convection through the little bubbles, especially if you look at it from a microscopical level. So how does it work? It stops heat from conducting through the air. We reduce the radiation and convection through cavities. So foam, bubble wrap, wool, and if you look at very, very good insulation, especially the ones that at the wall, they usually give you what? Aluminum foil or some kind of reflective surface to stop radiation. And we said before that everything radiates at the right temperature, and everything radiates even at small temperature. As long as you have temperature difference, there's always some kind of conduction or heat loss. So let's look at some R values for walls. This is standard 2x4 studs. That's what we get for R values, and you can see how it does change with the insulation. So this, the higher the R value, the better. Look at the insulating concrete foam. So these are concrete blocks with foam in the middle, and it's perfectly insulated. They put some kind of sheathing, and if anybody into construction, you know what is it like to skimp on the drywall. drywall prices varies heavily for thickness and what kind of sheets are in it. So you don't wanna skimp on that because it makes a big difference when it comes to heat loss. You can skimp on the ones between rooms, but the ones that are outside, you don't wanna skimp on that because it provides barriers for the humidity and moisture to travel, and it will also give you good insulation value, especially when it comes to the studs. Because usually you have a stud and you have drywalls on each side, so that area is completely conduction. I would say conduction is very effective in transferring heat. So if you don't have good insulating material on the drywall, probably gonna conduct like crazy from that stud. This is actually from the book, so you can look at it. So this is what's called a thermal bridging, where we have a drywall and we have conduction through the studs. And if you don't have the proper siding and insulation, probably you will have overall very low R value. So the typical low R value steel studs can be improved by insulating the sheeting as shown. So there is no way around conducting heat from the studs. Steel are better when they are in H or I shape. Is that what's called I-beam? The I-beams have a pretty small surface to conduct through in the middle, but you're still going to conduct part because it's metal. So if you don't have good thermal barrier, like the proper sheeting here and proper drywall, probably you will lose a lot of heat to the wall. Okay, I'll stop now and we'll finish this on Wednesday.